Alright guys, so as promised, as I told you I was going to make a key over the test, so let's go ahead and get started. I'm going to move a little fast in here because I don't want to make this video super long, so just pause as you need it, okay? So question number 1, you're being asked, I know it's a little blurred, it says on what intervals does the function f of x is it concave down? So to figure out concavity, I want to take two derivatives. So the function that you were given is f of x is equal to 1/12 x to the 4th minus 1/3 x to the 3rd minus 3 over 2x squared plus 8. So the first derivative, now it's going to give us 4 over 12 x to the 3rd minus x squared minus 6 over 2x. So the second derivative, so that's going to give us 12 over 12, which is 1, so it gives us an x squared minus 2x and minus 3. Okay, so this is a polynomial, so we're just going to set that equal to 0. So that's going to give us, let's go ahead and factor this out, x and x, so we got a minus 3 and a plus 1, which means x is equal to 3 and negative 1. So I'm going to go ahead and make a number line with this for the second derivative. So this is my second derivative number line. So there's negative 1 and there's 3. And if my second derivative is a quadratic that is positive, I know that at the endpoints I'm going to be going up, which means that on the endpoints I'm going to be positive. And the fact that I have two roots and each one of those roots has a multiplicity of 1 means I have to cross. So really what this graph looks like, it looks something like that. So I'm going to have a negative in there. So this is the graph of the second derivative, which means that anywhere the second derivative is positive, the original function is going to be concave up, and anywhere the second derivative is negative is going to be concave down. So according to this, you're going to be concave down between negative 1 and 3. So that's going to give us option number, letter A. Cool. Second question. You're given f of x is equal to, so f of x is equals 300x minus x cubed. We want to find out where you're increasing, so that's going to be the first derivative. So I'm going to take the first derivative, so that's going to give it 300 minus 3x squared. Once again, this is a polynomial, so we're going to set it equal to 0. So that's going to give me 300 is equal to 3x squared, which means 100 is equal to x squared, which means x is equal to plus or minus 10. I'm going to make a number line where this is negative 10 and this is 10. Once again, when I look at this, which is the first derivative, this is a negative quadratic, which means it's going to look something like that if I were to graph it, which means we've got negative, positive, and negative. The original function of f is going to be increasing wherever the derivative is above the x-axis or positive, which in this case is between negative 10 and 10. So that's going to give us option B. All right, question number 3 says, I know it's really hard to see, it says, what is the average rate of change? So we're looking for average rate of change when f of x is equal to x to the 4th minus 5x between 0 and 3. Guys, remember, average rate of change is literally just slope. So how do you find the slope? So m is going to be change in y over change in x. So in this case, we've got f of 3 minus f of 0 divided by 3 minus 0. Okay, so let's figure this out really quick. So if I plug in 3 into this equation, so 3 to the 4th power is going to give us 81 minus 15. And then if I plug in 0, it's just going to be 0. So that'll be 3. So 81 minus 15, that's going to give us a 66. Yeah, 66 divided by 3, that's going to give us 22. So your average rate of change is going to be the letter B. Okay? All right. Next option, it says if you have 3x squared plus 2x times y plus y squared is equal to 1, they want to know what the first derivative is equal to. So we got a little bit of implicit here. So we got 3 times 2, that's going to give us a 6x. Plus, this is where the implicit takes place. We have a product, so what I'm going to do is I'm going to go ahead and do a product there. I'll come back to it. I'm going to take the derivative of this. Y squared is 2y dy over dx, and the derivative of 1 is equal to 0. Okay, so let's go ahead and take this as a product rule. So I'm going to use this first. So the derivative of 2x is just going to be 2 times y plus, I'm going to leave the 2x alone, and the derivative of y would be 1 dy dx. Okay? So remember, with implicit, now we want to get all the dy dx's on one side and everything else on the other. So these parentheses are necessary now. So what I'm going to do is I have this 2x dy dx and then this 2y dy dx. So what I'm going to do is I'm going to have dy dx times 2x plus 2y. And I'm going to take this 6x and this 2y to the other side. So it's going to be minus 6x minus 2y, which means that dy over dx is equal to negative 6x minus 2y divided by 2x plus 2y. Now, I'm going to compare this to what I have, and I can see that none of these have a 6 or a 2, which means like I see 3's in here, which gives me a hint that what they're doing is factoring out a 2. So what I'm going to do is from the top, I'm going to factor out a negative 2, which is going to leave me with 3x plus y. And then on the bottom, I'm going to factor out a 2 as well, which is going to leave me with x plus y. So the 2's will cancel out, leaving me with a negative 3x plus y divided by x plus y, and that's going to match letter D. Okay? All right, moving on. We've got if f of x is equal to the sine squared of negative 4x plus 3, they want to know what f prime of 0 is equal to. So first what I'm going to do is I'm going to rewrite this in a way that it's going to help some of you guys, hopefully. I'm going to write this as that. So as you can see, this is going to be a chain rule. So we're going to do f prime is equal, so the chain rule is going to be 2 times sine negative 4x plus 3. The power goes down to 1. And remember, with the chain rule now, I got to take the derivative of this, which when I look at this, I realize this is going to be another chain rule. So the outer function is sine and the inner function is negative 4x plus 3. So the derivative of sine would be cosine. I leave the inside alone. And then I multiply by the derivative of the inside, which in this case is going to be negative 4. So now I'm just going to evaluate at 0. And hopefully this matches one of the options here. So we got 2 times the sine. If I plug in 0, that would be 3. And then cosine 3. And then I have a negative 4. So it doesn't match any of what I have here, but I do realize that negative 4 times 2 is going to give me a negative 8. Sine 3, cosine 3, which would be option A. All right. Find the instantaneous rate of change. Instantaneous rate of change means derivative of w with respect to z. So what I have is w is equal to 7 over 3z squared. So what I'm going to do is I'm going to rewrite this as 7/3 z to the negative 2. So now I'm going to take, I was told to take the derivative. So take the derivative with respect to z. So the derivative of w with respect to z, that's just going to be dw over dz is equal to, okay, this is just going to be a power rule. That's going to give me a negative 14 over 3. The derivative of z with respect to z, it's just going to be dz over dc, so that's not going to be a big deal here. So I'm going to have z to the negative 3. Remember, I got to subtract. So what I'm going to do is I'm going to rewrite this as negative 14 over 3z cubed, which then matches letter C. Okay? All right, it says find the following limits. If you're going to use L'Hopital's rule, make sure you justify it. Okay, so we've got the limit as x approaches 0 of sine pi x over sine 2 pi x. So if I plug in 0, that will be sine of 0, which is equal to 0. And then if I plug in 0, that will be sine of 0, which is equal to 0. So I'm going to be able to use L'Hopital's. Okay, so what that means is that I can take the derivative of the numerator and the denominator separately and repeat the process. So there's going to be a chain rule. So the derivative of sine pi x is going to be cosine pi x times the derivative of the inside, which is just pi. The derivative of sine 2 pi x is going to be cosine 2 pi x times the derivative of 2 pi x, which is going to be 2 pi. So now I'm going to just try this again. Plug in 0. So plug in 0. The cosine of 0 is equal to 1 times pi is pi. The cosine of 0 is 0 times 2 pi is 2 pi. So the pi's cancel out, leaving you with 1 over 2, which is option C. All right. Question number 8. It says, let the function be defined by f of x. So we got f of x is equal to the square root of the absolute value of x minus 2. For which of the statement is this true? So it says f is not continuous at 2. Well, we can try that real quickly. If you plug in 2, 2 minus 2 is 0. The square root of 0 is 0, so it is continuous. The function is differentiable at 2. Now, we got to then talk about what is happening at 2. Let's see here. So at 2, notice that if I plug in 2 here and I kind of ignore the square root, I have an absolute value. And I got to remember, absolute values have sharp points. So what I'm thinking here is that this is not going to be differentiable. So I'm going to kind of put that there. Oh, it says is differentiable. Okay, so definitely not. And then C, f is continuous. Yeah, we did prove that, but not differentiable. Okay, that's looking like my option. And then x of 2 is a vertical asymptote. It has nothing to do with asymptote, so it's going to be option C. You've got a sharp point, so it's not going to be differentiable. Okay? All right, question number 9. You've got f of x is equal to square root of x minus 4, so that's going to be x minus 4 to the power of 1/2. And then you got g of x is equal to 3x minus 2. They want you to find f of g of x. Okay, so f of g of x, okay, that's going to be equal to, all right, so let's think this through. For x, I'm going to put that in there, so that's 3x minus 2 minus 4 to the power of 1/2. So that's going to be what? 3x minus 6 to the power of 1/2. Then you're being asked to find the derivative. So we're going to take the derivative of this. So that's going to equal to 1/2 3x minus 6 to the power of negative 1/2 times the derivative of 3x minus 6, that's 3. And then you're being asked to evaluate it at x equals 3. So I'm going to go ahead and clean this up a little bit. So this 3 and this 1/2 is literally 3 over 2. And then this is just 1 over the square root of 3x minus 6. So I'm going to plug in 3 and see what happens. So we have 3 over 2 multiplied by 1 times. So 3 times 3 is 9. 9 minus 6 is 3. So that's square root of 3. So it's going to be 2 divided by 2 over times square root of 3. So number 3 right there. That would be option D. Okay. All right. Moving along. Part 10. Okay, so it's hard to read, but I'm going to go ahead and rewrite it. It says the limit as h approaches 0 of the natural log of 4 plus h minus ln 4 over h. Okay, first of all, right away you should recognize this. This looks like f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h, which means this is the derivative. This is the derivative of this function. So now what I notice is that the function, in order for me to be the derivative with respect to x, there has to be x's. Notice that there's no x's. So what I recognize that instead of x, you see I have x plus h, I notice that x is equal to 4. So what that means is that f of x for this function is ln x. So this is the derivative, which means that f prime is going to be 1 over x. Now remember, x is equal to 4, so that means that this is literally asking you what is the derivative evaluated at 4, which would be 1/4. You could have also used L'Hopital's rule to solve this problem. Okay? All right, next problem. We have y is equal to x squared sine 2x. They want to know what the derivative is. Okay, so y prime, we got a product rule. So the product, I'm going to do the derivative of the first, which is 2x sine 2x, and then I'm going to add. I'm going to leave the x squared alone. I need to multiply by the derivative of sine 2x, which is a chain rule. The derivative of sine 2x would be cosine 2x multiply by the derivative of the inside, which would be a 2, so I'm going to put it up front. Now, none of this match this, but what I noticed just by my options is that it seems like they have factor out of 2x. So I'm going to factor out of 2x, so it's going to leave me a sine 2x for this one, plus it's going to leave me with 1x here, and then cosine 2x for the second one. So I'm going to see if I can find anything that matches, and that will be option C. All right. Number 12. The function f of x, so you've got f of x is equal to x over x plus 2. It says, where is this function have a tangent line with a slope of 1/2? So, okay, so m is equals to 1/2. So we want to figure out where this has a slope of 1/2. So what that means is I need to find where this, I need to remember and make the connection. The slope is derivative, so I'm going to take the derivative of this. So what I'm going to do is I'm going to go ahead and use a quotient rule. Why not? So it's be x plus 2 times the derivative of x, which is 1, minus x times the derivative of x plus 2, which is 1, all over x plus 2 squared. So I'm going to clean this up a little bit. That's just going to be x plus 2 minus x. So it's just going to be 2 over x plus 2 squared. And I'm going to set that equal to 1/2 because I want to know what x values is going to give me a slope of 1/2. So I'm going to clean this up. So I'm going to cross multiply. So 2 times 2, that gives me a 4, and then 1 times x plus 2 squared, that's going to give me x plus 2 squared. I'm going to take the square root of both sides. So the square root of 4 is going to be plus or minus 2, which is equal to x plus 2, which means x is equal plus or minus 2 minus 2. So 2 minus 2 is going to give me 0, and then negative 2 minus 2 is going to give me negative 4. So it looks like I'm looking for points, but before I go and find the y coordinates, let me see if there's anything that just has 0 and negative 4 as x values. So it's definitely not A. It's definitely not D. Notice how B says 0, 0, and then 4 2/3, and C says 0, 0, negative 4, 2. The fact that I need a negative 4 then automatically tells me that it's going to be option D. So I'm not going to waste my time trying to figure out the y values. Okay? All right. Question 13 says you are given the following function. F of x is equal to negative x squared plus 12x minus 36. You are being told that you have a maximum at x equals 6. Choose the correct statement. Okay, well, let's think this through. If you have a maximum at x equals 6, what that means then is its first derivative, without really finding it, which by the way we can, it's going to have a critical number at 6. And in order to have a maximum, you would have to first be increasing, and then you would have to be decreasing. So that means that the first derivative has to be positive from negative infinity to 6 and negative from 6 to infinity. So let's see what the options are. F prime is positive from 6 to infinity. No. F prime is negative from 6 to infinity. Yes. F prime is negative from negative infinity to 6. No. F prime is negative on the, nope, on the entire interval. If it was negative on the entire interval, we could not even have a maximum. So by process of elimination, it has to be choice B. All right. 14. So you are given x squared plus y squared is equal to 25. They want to know what the second derivative is equal to at 3, 4. Okay, so we're going to take the derivative. Derivative of x squared is going to be 2x. Derivative of 2y is going to be 2y dy dx. Derivative of 25 is 0. I'm going to make my life easy and recognize that everything's divisible by 2. So that means x plus y dy dx is equal to 0, which means dy dx is equal to negative x divided by y. So I subtracted the x and divided by y. So I need to find now the derivative of that. So the derivative of the first derivative, that's going to be your second derivative with respect to x. Now I'm going to use a quotient rule. So it's going to be y times the derivative of negative x would be negative 1 minus, we've got negative x times the derivative of y, which is 1 dy dx, all over the denominator square. So now I'm going to not clean this up. I'm going to go ahead and plug in what I know and 3/4. So y squared in this quote is going to be 16. That's 4 squared. So we got 4 times negative 1. That's going to give me a negative 4 minus a negative x is going to give me a negative 3. Now dy dx is negative x over y. So I'm going to go ahead and keep going over here. Okay, so what do we got? We got negative 4. Negative and negative give you a plus 3. Now x is going to be negative 3. Y is going to be 4. And then we've got ourselves a 16. All right, so a little bit more cleaning up to do. So negative 4 plus, what do we got? Negative 9 over 4 over 16. All right, so I'm going to get a common denominator here. The common denominator is going to be 4. So it's going to give me negative 16 minus 9 over 4 divided by 16. All right, so negative 16 minus 9 is going to give me a negative 25. And then 4 over 16, that's going to give me a 64. So that means that it is going to be negative 25 over 64, which would be option B. Oh, no. Yes. All right. 15. So we've got a function, and you've got x cubed. Find the value that satisfied the mean value theorem. Okay, mean value theorem, remember, says that there has to be a place where the average rate of change, so average rate of change is equal to the instantaneous rate of change. So we're going to start out by finding the average rate of change. So we've already done this in this test. So the average rate of change for this one is going to be equal to change in y over change in x, which in this case is f of 3 minus f of 1 divided by 3 minus 1. Okay, if the function is, by the way, it's hard to see, the function is x to the third power. That will be 3 to the third power, which is going to be 27, minus 1 to the third power, which is 1. 3 minus 1 is 2, so that's going to give me 26 divided by 2, which gives you 13. So that's your average rate of change. Average rate of change has to be equal to the instantaneous rate of change in order for the mean value theorem to work. So the instantaneous rate of change is just a derivative. So f prime for this case is going to be 3x squared. So we're going to set this equal to 3x squared and figure out what is the x value, or in other words, they're calling it c value for this to work. So I'm going to divide both sides by 3 and then take the square root of it. So x is going to be equal to the square root of 13 over 3, which should be option B. Okay? All right, the next is we're going to use a table to help us out. So you are being told that g of x is equal 1 over f of x. You want to know what is g prime of 2 is equal to. So that means I got to take the derivative of this. So I'm going to use the quotient rule here. So I'm going to do f of x times the derivative of 1, which is 0, minus 1 times the derivative of f of x, which is going to be f prime of x, all over f of x squared. So I'm just going to now plug in 2. So that's going to be f of 2 times 0 minus f prime at 2 all over f of 2 squared. Okay, so that part's gone, so it's going to be negative. All right, so f prime of 2. So now, if I look at the table, here's 2. F prime is negative 4. And then f of 2. So f of 2 is negative 8. Negative 8 squared is 64.
Hey, Lions, come join us for the afternoon edition of Family Feud. Test your useless knowledge as we battle it.
Yep, sorry about that. We got some kind of, I guess, Jeopardy or something. I don't know, Family Feud or something. Anyways, going on here on campus. So negative of negative, that gives us a 4 over 64. These are both divisible by 4, so it's going to be 1 over 16, which gives us option C. Okay? All right, I know I'm going a little fast, guys, but I really don't want to stay here another hour after work or so. Okay? So, 17. You are giving a function. So, the function that you are given is f of x is equal to 3x to the 5th minus 5x to the 3rd minus 8. We are looking for a minimum, which means we're going to do the first derivative. We're going to make a number line, and we're going to figure out where we're increasing and decreasing. And in order for us to have a minimum, wherever there is a change between decreasing to increasing, that's where we're going to have a minimum. So, let's go ahead and do that. So, f prime. 5 times 3 is 15. This becomes x to the 4th. 5 times 3 is 15. This becomes an x squared. And the derivative of 8 is gone. So that makes this a little easy. We're going to set this equal to 0. They both have a 15x squared in common, which means I would have an x squared minus 1 equaling to 0 there. So if I set this equal to 0, that would mean x is equal to 0 with a multiplicity of 2. And then this would be x is equal to plus or minus 1. So what I'm going to do is I'm going to make a number line here. So I've got negative 1, I got 0, and I have 1. Each one of these has a multiplicity of 1. So here's what it means. If I were to graph this, this is a quartic with this positive leading coefficient. So what I do know is that the end behavior is going to go like that. And when I get to 1, if the multiplicity is 1, I got to cross. And then when I get to 0, the multiplicity is even, so I've got to bounce. So it's going to look something like this. Remember, you don't have to be doing this, by the way. I'm just showing you this in order for you guys to have a pictorial representation of what it means. So before negative 1, you're above the x-axis, then you're below, and then you're above. Remember, the other way to do this is you could have picked numbers in between negative infinity and negative 1, plugged it into here, anything between negative 1 and 0, 0 and 1, and then 1 to infinity, and it will match this behavior. So now, to have a minimum, you would have to go from decreasing. Decreasing is represented by a negative. So here's a negative, and next to it has to be a positive. So it would not be at 0. From negative 1, from 1 right here, on the left side is negative, on the right side is positive. So if we're decreasing to increasing, there has to be a minimum here. So that's going to be at C. Okay? All right, question 18. The graph of f prime, so this is very important, this is f prime. The derivative is shown into the figure. Which of the following describes the relative extrema of f? Okay, so I don't know values, but here's what I know. If I make a number line of this, okay, so here's A, and here's B. Notice that I have 1, 2, 3 places where I have zeros. I don't know what they are, but here's what I do know. This is where this kind of helps me out. Notice how before the 0 you're below, so that's going to be negative. After that 0 you're above, and then below, and then above. So using this graph, I was able to obtain basically the number line. So I'm just going to figure out what we have. If we have decreasing to increasing, that's going to be minimum. If we have increasing to decreasing, that's going to be a maximum. And then decreasing to increasing, that's going to be a minimum. So we're going to have 2 minimums and 1 maximum. So option A says 1 maximum and 2 minimum. Okay, so that's going to be it. Option A. Alrighty. Question 19. A particle moves along the x-axis in such a way that the position is given by x of t is equal to 1 minus t over 1 plus t. What is the acceleration when time is equal to 0? Okay, so in order for me to find the acceleration, I have to take the second derivative of this. So we know that xt is equal to 1 minus t, 1 plus t. So I'm going to do a quotient rule. So x prime, that's going to be 1 plus t multiplied times the derivative of 1 minus t is going to be negative 1 minus. I'm going to leave the 1 minus t alone. The derivative of 1 plus t is going to be 1 all over 1 plus t squared. So I'm going to go ahead and clean this up. So this right here gives me a negative 1 minus t minus 1 minus t all over 1 plus t squared. Oh, sorry, this should be a plus t, right? Because I've got to distribute, this would be negative 1 plus t. Alright, so it actually makes things a lot easier because these two are going to cancel out, which I'm running out of space, but what that means is that x prime of t is equal to negative 2 over 1 plus t squared, which is the same thing as saying negative 2 times 1 plus t to the negative second power. So I'm going to do the second derivative so I can find the acceleration. So negative 2 times negative 2 gives me a positive 4. 1 plus t, I'm going to subtract 1, so that gives me negative 3. The derivative of 1 plus t is just going to be 1, so in this case it's just going to be equal to 4 over 1 plus t to the third power. Now they want to know what the acceleration is when t is equal to 0, so if I plug in 0, that's going to be 1 plus 0 cubed, that's just going to be 1, so 4 over 1 is 4, so the answer is going to be D. Okay? Number 20, we've got what is the derivative of arctangent? Okay, so the derivative of arctangent, let's go ahead and refresh. The derivative of arctangent, so arctan of u, that's going to be equal to u prime over 1 plus u squared. So that's going to be very simple. Okay, so in our case, we've got arctangent of e to the 2x. So that's going to be u right here. So u is e to the 2x. So u prime is going to be 2 e to the 2x. So in our case, that's going to be 2 e to the 2x divided by 1 plus e to the 2x squared. So that's going to give us 2 e to the 2x over 1 plus e to the 4x. D's out of the way. C's out of the way. Definitely A. It's going to be B. Okay. All right, 21. We've got a product rule. We've got a chain rule. We got some natural logs. It says to find the derivative. Okay. So we're told that y is equal to x times the natural log of x squared. So y prime, we're going to do a product first. The derivative of x is just 1 times the natural log of x squared plus, we're going to leave this alone. Now the derivative of this is going to be a chain rule. So that's going to be 2 times ln of x. That goes down to 1 times the derivative of the inside. The derivative of natural log of x is 1 over x. So now it's just clean up time. So that's just going to be ln of x squared plus this x times this 1 over x is gone. So I literally just have 2 ln of x. None of this match, but just by the answers, I can see they factor out ln of x. So if I do that, if I take out an ln x, then that leaves me with 1 ln x here plus 2. So that would be option C. Alrighty, number 22. The figure shows the graph of the derivative. Okay, this is key. The derivative. So this is f prime. Okay. How many points of inflection does f have? Okay, points of inflection are when we change concavity. Okay, and to find that is we set the second derivative equal to 0. Okay, so we need to have the second derivative equal to 0. Now, why equal to 0 is because this is a polynomial, right? We're not going to have anywhere there that we're going to be undefined. So here's what I know. Okay, the second derivative is equal to 0. If I have the first derivative, but I don't actually have the equation, then I will need to take the derivative of this and set it equal to 0. Now, I want you to think this through. If I take the derivative of f prime, that's going to give me the slopes of f prime. So if I want to set it equal to 0, I just need to look in this graph and figure out where are the slopes on this graph equal to 0. And that's going to be at this location, this location, this location, and that location, which gives me 4 possible points of inflection. Now notice how I am switching from, so on my second derivative, I can make a number line, okay? I'm going to go ahead and have 4 locations, so 1, 2, 3, 4. Now, if I'm analyzing the slopes of f prime, that's what the f double prime would do, okay? Notice how I am increasing, which means that the second derivative would have to be positive there. And then I get to 0, and then I am decreasing, which would mean negative. And then I am increasing, which would be positive. And then I'm decreasing, which is negative. And then I'm increasing, which is positive. So this would be your number line for the second derivative. Notice how there's an alternation in between all of them. That means we have 1, 2, 3, 4 points of inflection. That'd be 22. Okay? All right, hang in there. We're almost there. I'm also just tired of talking myself as well. Okay, so let me go ahead and flip on to the next one. So you have a function, and that function is equal to 4x to the third minus 5x plus 3. It says find the tangent line. So we want a tangent line at x equals -1. So we need 2 things. In order to find a tangent line, we need a point and we need a slope. All right, let's figure out the point first. So let's figure out what f of -1 is. So that will be 4 times -1 to the third minus 5 times -1 plus 3. So -1 cubed is going to be -1 times 4 is -4. -5 times -1 gives you +5 plus 3. So that's 5 minus 4 is 1. So that's going to give you equal to 4. So that means we have a point at -1 comma 4. Now we need a slope. Slope means derivative. So I'm going to take the derivative. So this is going to be 4 times 3 is 12, x squared minus 5. So where do I want the slope? I want the slope at this point, so I'm going to plug in -1. So f prime of -1. So it's going to give me 12 times -1 squared minus 5. So that's going to give me 12 minus 5, which gives me a 7. Which then at that point, if the slope is 7, then just by process of elimination, I can get rid of d. Okay? So now I'm going to use my point slope form. We know that y minus y1 is equal to m times x minus x1. So I know my slope is equal to 7. I know the y value is 4, so that's going to be y minus 4, 7x, and then minus a -1 gives you +1. So I'm just going to clean this up into slope-intercept form. So that's going to give me what? 7x plus 7. I'm going to add the 4, so +4, and that's equal to 7x plus 11. So that's going to be option C. Okay. All right. We've got a natural log. So remember the derivative with respect to u of the natural log of u is equal to u prime over u. So that's what we're going to do here. So f prime. Okay, so u is just x plus 4 plus e to the -3x. So u prime is just the individual derivatives. The derivative of x is just 1. The derivative of 4 is 0. And this would be a chain rule. The derivative of e to the x is going to be e to the e to the u times u prime, which in this case is -3. So this is equal to, what do we got? 1 minus 3 e to the -3x over x plus 4 plus e to the -3x. They want it evaluated at 0. So f prime of 0 is going to give me 1 minus 3 e to the 0 over 4 plus e to the 0. Okay, so 3 e to the 0. E to the 0 is just 1. So it's going to be 1 minus 3, which gives me a -2. And then e to the 0 is 1. 1 plus 4 is 5. So it's going to be -2/5, which is option A. All right. Okay. So it says, it's hard to read, so stay with me. It says the volume of a sphere is given by, okay, so we got a sphere, and its volume is 4/3 pi r cubed. the volume of gas filled spherical balloon increases 6 cubic inches for each degree Celsius in temperature. Okay, so what you were just given is a change. If you have cubic inches per degree Celsius, that means that you were given a change in volume over a change in temperature. And the fact that it says increases means it's going to be positive, so this is going to be equal to 6 cubic inches per degree Celsius. All right. Now it says if the temperature increases at a constant rate of 2 degrees per minute. All right, so hold on. So temperature is increasing per time. So what you're telling is the temperature is increasing in time by, and it's increasing, it's going to be positive, 2 degrees Celsius. So that's going to be degrees Celsius over time, which in this case is minute. Okay. It says at what rate is the balloon is the radius of the balloon? So we're looking, so what rate is the radius changing over time when the volume is equal to 36 pi cubic inches? All right, so that's all the information that was given to us. Let's see what we got. We're going to have to take the derivative of this so that we can get dr dt. So we're going to take the derivative of this with respect to time. So the derivative of volume with respect to time, that would be dv dt. And then the derivative of 4 pi r cubed, that would be 4 pi r squared dr dt. Now this is what we're looking for. I need to know what r is, and I need to know what dv dt is, which it seems like I don't have any of that. However, this information that I have here should help me figure out. Okay, if you have the volume, so we know that volume is equal to 4/3 pi r cubed. But you actually have the volume, so it's going to be 36 pi is equal to 4r pi r cubed. So the pi's are gone. Let's see, I'm going to multiply by 3/4, so that's going to be 36 times 3/4 is equal to r cubed. Sorry about that, it's off the page. All right, so 36 is divided by 4, right? So it's going to be 9. 9 times 3 is 27. So 27 is equal to r cubed, so r would have to be 3. So we know what r is now. So now we need to know what dv dt is. So the only thing that I can think of is to use this information right here. Well, let's think this through. If the volume is changing as the temperature is changing, but the temperature is changing over time, then there should be a way for me to combine this. So I'm going to ignore these numbers for the moment, and here's what I know. Okay. So I'm going to ignore the units. Okay. So I know that dv dt, dv, change in volume over change in temperature, is equal to 6. And then I have change in temperature over change in time is equal to 2. So here's what I'm going to do. I want change in volume over time. So what I'm going to do is I'm going to solve this for change in temperature. So that's going to be change in temperature is equal to 2 dt. And what I'm going to do is I'm just going to replace this change in temperature on this one. So it's going to be dv over 2 dt is equal to 6. Perfect. So now I just need dv over dt. So dv over dt is going to be 12. And think about it. The units is very easy to come up with. Change in volume over time. So the volume is being measured in cubic inches. And then the time is being measured in minutes. So you've got dv dt. You've got your radius. We got everything we need here. So what I'm going to do is in order for me to solve for dr dt, I'm going to divide everything by 4 pi r squared. So I'm running out of space. So dr dt is equal to dv dt divided by 4 pi r squared. I'll do a little bit of... Alright, so let's see what we got. So dr dt, I'm going to go here, okay, is equal to, alright, dv dt is just 12. Okay, 4 pi, and then r is 3, r squared is 9. So dr dt, what do we got here? So 9 times 4 is 36, so it's going to be 12 over 36 pi. These are both divisible by 12, so it's going to be 1 over 3 pi. And then the units for the radius is going to be what? Inches per minute in this case. And that would match option C. This one was a little tricky, okay? But good question, actually. By the way, let me remind you, all of these questions that you took for this test, for the most part, are from past AP exams, okay? All right, we're almost done. It seems like I think we have 2 or 3 more questions. Okay. Number 26. The graph of f of x is shown at the right. So the graph is shown. Which one could be the graph of the derivative? Okay, so first of all, I want you to notice this. The graph of f of x seems to be increasing and then decreasing. So that means it has a maximum. So that means its derivative, in order for this to be true, from here to here, so whatever this is, from here to here, if this is increasing, that means that on that f prime, so if I do a number line like this, for f prime, would have to be positive from here to here and then negative. So let's look at which ones offer those options. So b is positive and then negative, so that could work. D is positive, negative, positive. It doesn't have this, so it can't be that. C is negative and then positive, so it can't be that. And then A is positive and then negative, so it's between A and B. So now let's think this through. Okay, this is where some logic comes in. If this is f of x, can it, even though I don't know the function, can the derivative of this curve be a line, or would it be another curve? Well, if I think this through, this is kind of like sine or cosine, so the derivative of each other is sine or cosine. It is more likely than by common sense here that it has to be A, it can't be B. I can't get a linear out of this curve. Cool? All right. 27. A farmer wants to fence a rectangular pasture adjacent to a river. The pasture must contain 275,000 square feet in order to provide enough grass for the animals. No fencing is needed in all the river. Okay, so we got a river here, and he wants to do a rectangular pasture. I'm just going to call this y, and I'm going to call that x. What dimensions will it require to be the least amount of fencing? Okay, so here's what I know. I know that x times y has to give you 275,000. That's the area. But I also know that as far as to figure out the fencing, I know that 2y plus x would have to give you your perimeter. Which, by the way, that is what I want to figure out, what I want to minimize. So here's what I'm going to do. If I want to minimize this, I need to get this statement in terms of one variable. So I'm going to solve this for one variable. This for one variable, take the derivative and see where it takes me. So here we go. I'm going to to make my life easy, I'm going to solve for probably x. So x is equal to 275,000 over y. So that means that 2y plus x, so I'm going to do 275,000 y to the negative 1 is equal to p. So I'm going to take the derivative, p prime. So it's going to give me 2 minus 275,000 y to the negative second is equal to p prime. So really what this means is this is 2y squared minus 275,000 over y squared is equal to p prime. Now, if I want to minimize this, that means I need to find out where this is equal to 0. Okay, now we can't have 0 dimensions. So I'm going to set this equal to 0. I also need what's undefined, but it's not going to matter because that's 0. So I'm going to set this equal to 0. So it's going to be 2y squared is equal to 275,000. I'm going to divide that by 2. So y squared is equal to, what would that be? 275. So divided by 2. That's going to be 1, 3, 5. Am I right? 5. Let me make sure. 7. No, 1, 3. No, 7. Yeah, 7, 5. Which means that y is equal to the square root of 137,500. So now if I make a number line, I'm going to make a number line up here. It's going to be unnecessary, but I'm just going to go ahead and prove it. We can't have dimensions less than 0. This is going to be the square root of 137,500. I'm sorry. Now let's say I plug in 1. If I plug in 1 here, 2 times 1 is 2 minus that is going to be negative. So it's definitely going to be negative. And then if I plug in something after that, so let's say I actually plug in 137,500, right? Because that's definitely bigger than the square root. If I square that, that's going to be 137,500. Squared is going to give me, I'm sorry, times 2. And then minus that is going to give me a positive value. Sorry, I'm rambling here a little bit. Okay. if I choose, yeah, 1/3 square is going to be definitely bigger than, yeah, basically, yeah, sorry. Okay, so times 2, definitely plus. All right, so what that means is that if we go from negative to positive, that's going to be a minimum, which is what we're trying to do. We're trying to require the least amount of fencing, which is the minimum. So that means here's what we know, that the y value would have to be the square root of 137,500. And then by default, I'm going to plug that into the x equation, which would be equal to 275,000 divided by the square root of 137,500, which I do not need you to clean up. That should be good enough. Okay? All right, 27 is out of the way. And lastly, 28, it says to sketch a graph where you have f of 0 and f of 6 equal to 0. Well, you got all this. Okay, so let's go ahead and start that. So f of 0, and then let's call that 6, is that. So that's taken care of. Now it says f prime of 3 and f prime of 5 is equal to 0. So I'm going to make a, so 3 and 5 is equal to 0. The derivative is greater than 0 for values that are less than 3, so it's going to be positive. The derivative is greater than 0 between 3 and 5, so that's going to be positive. The derivative is less than 0 for numbers that are bigger than 5, so that's going to be negative. So let me check. Greater between 3. Okay, so we got that going on. So this is for f prime. Now f double prime, we've got the double derivative is less than 0 when x is less than 3. Okay, so 3 and 4 and greater than 4. So it's going to be negative and negative. So that's that part. And then the second derivative is bigger than 0 between 3 and 4. So it's going to be positive. So that's the concavity. All right, so let's talk this through. So I have to have a point of inflection here and a point of inflection here. And then we're going to have some type of maximum here. So I'm going to go ahead and kind of play out with that idea. So let's call that 5. I'm going to have some type of maximum. I don't know. I'm going to say about that right there. Okay. So here's what I know. I'm going to use, so 3 seems to be an important point. So I'm going to do 4, 3, 2, 1. So at 3, I got to have a point of inflection. So I'm just going to plot a point right there. I have a point of inflection. But then at 4, I also have a point of inflection. Let me take it step by step. So before I get to 3, I should be concave down but increasing. So concave down is this. Concave up is that. So if I'm going to be concave down but increasing, that has to be this part. So it's going to look something like this. So it's going to be concave down but increasing. Okay. And then when I get to 3, I need to change to concave up but increasing. So concave up would be this, and increasing is going to be this. Okay. And then when I get to 4, I got to change concavity. So here's what I got to change the concavity right there. So I got a point of inflection. And then I have a 5. Then I got to be concave down afterwards. So concave down. Look, I have a concave down. And then increasing until I get to 5, but decreasing after that. So I'm going to do decreasing. So it's going to look something like that. Something like that. And that should be my final answer. All right. I try to keep this as short as I could. It's about 50 minutes. If you have any other questions, please let me know. Take care, guys.